Hello everyone and welcome to my channel. In this tutorial I will show you how to create a multi-boot USB from scratch. We will not be using third-party software. We will go down to the low level and use standard Linux command line tools. This way you will understand how it works and will be able to customize multi-boot USB for your specific needs.
These are the prerequisites for this tutorial. A Linux virtual machine, basic experience with Linux command line. You don't have to be an expert, but you need some basic experience, basic understanding of partitions and file systems, bootable images ISOs that you want to put in the USB, and of course a USB stick. I will teach you how to fully customize a multi-boot USB from scratch with an example. I will put the excellent Strelec WinPE recovery tool, Windows 10 installation, and Ubuntu Live Image. The rest of the USB space will be allocated for an NTFS general purpose storage partition. Of course, this is only an example. After you will understand this example, you will be able to fully customize your multi-boot USB to boot whatever images you want. I split the tutorial into the following sections: a quick overview of the boot process, partitioning the USB, installing and configuring the GRUB bootloader, testing the USB, and backup and restore of the USB image. To customize a bootable USB, we must understand the boot process. When we power on the computer, the CPU and the RAM are not initialized. The computer has to start somewhere, and the firmware, also known as UEFI or BIOS, is the first program that the computer runs. It's a small and simple program that is loaded from a flash chip on the motherboard. Its purpose is to find all storage devices, read the partition tables, figure where the bootloader is, and run it. The bootloader is another small and simple program. Its purpose is to find the operating system and initialize it. The kernel is another computer program, but much more functional. It provides full set of system functions for processes to handle hardware resources. After the kernel is loaded, the operating system can be initialized and all the user space software can be run. Where do we find the bootloader? The bootloader is found in the EFI partition of the operating system disk. In a Linux machine, I will run parted to find the EFI partition. I will run df to see where the EFI partition is mounted. I will switch to the root user and go to the EFI partition. The bootloader is always under EFI boot. This file, bootx64.efi, is the bootloader. In Windows, it's the same. We have an EFI partition. I will use mount vol to mount it to X. I will go to X, and the bootloader is again under EFI boot. This one, bootx64.efi, is the bootloader. In this tutorial, I will show you how to compile a GRUB bootloader into a USB. The firmware will locate and run the bootloader, and we will configure the bootloader to locate and initialize the bootable images in the USB partitions. First, we will partition the USB. I will assume UEFI firmware and create GPT partition table. This is the standard and should boot every PC or laptop from at least the past 10 years. If you want to learn about legacy BIOS and MBR partition tables, there are many resources online. From this point, I will be using a Linux Mint virtual machine. Do not run this tutorial on a production Linux system. we will be running sensitive partitioning and file system commands that may break the system if executed incorrectly. First, let's figure how many partitions we need. I want my USB to boot the Strelec WinPE, Windows 10 installation, and Ubuntu Live USB. The rest of the space will be allocated for a general purpose storage partition. Because of how the Windows bootloader works, we need each Windows image to be on a separate partition. So, in this case, we need 4 partitions. The EFI partition, a partition for the Strelec WinPE, a partition for the Windows 10 installation and the Ubuntu Live USB, and a partition for general purpose storage. Then we need to identify the USB. I connected a 16 GB USB to the virtual machine. I will use the df command to see all the mounted file systems, and I can easily see from the size and from the label that SDC is the USB. After planning the partition scheme, it's time to do the partitioning itself. I wrote 2 scripts. The first will unmount the USB, create a GPT partition table, create 256 megabytes partition and set it as EFI partition, create 2 partitions for the images and 1 partition for the general purpose storage. The second script will create FAT32 file system on the first partition and NTFS file system on the other partitions. Let's run the scripts. Let's run parted to see if it worked. And we have 1 FAT32 partition set as EFI partition and 3 more NTFS partitions, so this is good. After successfully partitioning the USB, it's time to copy the images to the USB partitions. This script will create mounting points and mount the images, create mounting points and mount the USB partitions, create a directory for the Ubuntu image, and copy the images to the USB partitions. Let's run the script, and it's going to take some time. It seems the copy has completed. Let's check it out. This is the Strelec image. This is the Windows 10 image. And this is the Ubuntu image. Copying the images to the USB partitions is all good, but will not make your USB bootable. To make a USB bootable, we have to install a bootloader in the EFI partition of the USB. In this part of the tutorial, I will show you how to install the GRUB bootloader. This is a free, open source, simple and flexible bootloader and a much better solution compared to the Windows bootloader. Installing GRUB is very straightforward. We will clone the source code of GRUB, build the binaries, and install it in the EFI partition of the USB. To install GRUB on the EFI partition of the USB, follow the following steps. Install needed software. Clone the GRUB source code from Git. Switch to the root user. Go to the directory where the GRUB source code is. Run the bootstrap script. Configure the installation for 64-bit UEFI. Build the binaries. Go to the GRUB core directory. Make sure the EFI partition is mounted at MNT EFS. And install GRUB on the EFI partition of the USB. Installation finished with no errors. We should have a bootloader under EFI boot. Congratulations, we have a bootable USB. If you successfully installed the GRUB bootloader and booted from it, you should get a shell like this. Technically, I can type commands in the shell and boot the images. But of course I prefer a graphical menu, and this is what we are going to do next. To customize the GRUB bootloader, create a file grub.cfg in the boot GRUB directory. GRUB configuration is a topic on its own. There are many resources and references online. I will show you a very simple example to boot the images in the USB we created in this tutorial. I created a menu entry for each image and to reboot and shut down. To boot a Windows image, we will call the Windows bootloader with a chain loader command. This is the reason why each Windows image has to be on a separate partition. To boot Linux live images, the commands are different for different distributions. You can read the configuration file of the image itself and look for online references. Anyway, these commands will boot the Ubuntu live image. The default and timeout settings tell GRUB which entry to boot after the timeout passed and no entry was chosen by the user. After creating the GRUB configuration file, you should see a menu like this. Let's try, for example, to boot the Windows 10 image. Give it a few seconds. And it's up. What if you corrupt or lose or just want to duplicate the Multiboot USB you created? We don't want to go through this tedious process anytime we want to create a copy of the USB. In this section, I will show you how to easily backup and restore the USB. Making a USB or any storage device image is very easy and can be done with a single command. This command will copy, bit after bit, the contents of the USB, including the partition table, to the multiboot.iso file. It's going to take a while. After the cloning is done, you will have an ISO file that you can use to duplicate the image to another USB. I connected a 32 GB USB to the virtual machine and unmounted it. To restore the image to a USB, we will use the same command but reverse directions. This time we will copy from the file to the USB. And it's going to take a while. After we copied the image to the USB, there is one last thing to do. We copied 16 GB image to 32 GB USB, which means we have extra 16 GB we can use. Let's take a look. Let's print the partition table and choose to fix it. and we can see that the fourth partition ends at 16 gigabytes. Let's extend it to 32 gigabytes. Let's print again. And now we can see that the fourth partition ends at the end of the USB, which is good. Now let's create a new NTFS file system in the extended partition. And this is it. We created a Multiboot USB with a general purpose storage partition and took an image of it. I hope you enjoyed this tutorial and found it useful. Thanks for watching.